In this lesson, we'll be discussing how to represent a vector using different bases. The question reads, let S represent these three vectors, where the three vectors have the following components. What we're expected to do is find the coordinate vector of v with respect to x, that's part A, and in part B, find the vector v in 3D space whose coordinate vector with respect to the basis S, represented as v sub s, is equal to the following three components. So starting with A, we have to find the coordinate vector v with respect to S, and we can do this by representing v, 2, 1, and 0 being equal to each of these vectors multiplied to a scalar. And remember, scalars are constants. So vector 1 being multiplied to k sub 1, the first scalar, plus vector 2 being multiplied to another scalar, plus vector 3 being multiplied to the third scalar. Once we have it written this way, we can now set up our equations. Our first equations will relate the x components, second being the y, and third being the z components. Here's what I mean. So I'll write down k sub 1 times 1 is k sub 1, plus 2 times k sub 2 minus 1 times k sub 3, and that is equal to 2. Let's do the same thing for the next component. K sub 1 times 0 is 0. We can forget about that. Then we have k sub 2 plus 2 times k sub 3, and that's equal to 1. And our last equation will be negative k sub 1, that's 0. So I'll write down plus 0. And k sub 3 is equal to 0. We now have to convert this into a matrix. And what we're looking for here is k. So if we convert this into a matrix, our matrix will look like this: 1, 2, negative 1, 0, 1, 2, negative 1, 0, 1, 2, 1, and 0 down that column. Now to find the scalars, we have to put this in row reduced echelon form. So I'll make reference to that. And if you do this correctly, you should end up with a matrix that looks like this: 1s across the main diagonal within that n by n matrix, and the answers will be along here. The answers will be 13 over 4, negative half, and 5 over 4. What this tells us is that k sub 3 is equal to 5 over 4, k sub 2 is equal to negative half, and k sub 1 is 13 over 4. Now the way we write this is by stating the representation of v with respect to s is equal to the answers we found: 13 over 4, negative half, and 5 over 4. Now once again in part B, we have to find the vector v in 3D space whose coordinate vector with respect to the basis s is shown here. So we're technically doing the opposite of what they ask in part A. All we really have to do is represent the k's like this as negative 1, 2, and negative 1. So negative times the first vector, these are technically k sub 1 through k sub 3, plus 2 times the second vector minus 1 times the third vector. If we multiply this out and take the sum, we should end up with a vector that has the components 4, 0, and 0. Just to give you an idea, negative 1 plus 4, that's positive 3, plus 1 gives you 4, and the same math can be done for the other components. And there you have it. That is how to represent a vector using different bases.